Unit 1, Lesson 2, instructional video on segments. Is your vocabulary done? Line segment, midpoint, segment bisector, and segment addition postulate. First thing in your notes, notation of segments. Name each colored line segment. There are 4 different segments here. There's a blue one, a green one, a red, and a yellow. When we name line segments, we use both endpoints with the line segment over top. The order of the endpoints does not matter. Green one goes from A to G with the line segment on top, or G to A. E to F, or F to E. If you take a look at the yellow one, there are 3 points on this line segment. When we name a line segment, we need to name it by the end points. B is one endpoint, C is the other. BC or CB with the line segment on top. If you were to call this BH, you'd be referring to a line segment from B to H, and while that is a line segment, it's not the entire yellow line segment. Next thing is the difference between AB with that line segment on top of it versus AB without the line segment on top of it. Again, in geometry, you need to make sure that you say what you mean and mean what you say. These do have different meanings, slightly different meanings, even though they look to be about the same. So the first one, when you have AB with the line segment on top of it, you're referring to the physical line segment. You're discussing this thing as an object, the line segment from A to B. When there's no line on top, what you're referring to now is the measurement of the line segment from A to B. Seems kind of silly. Why on earth would anybody care to talk about the different things? If you're thinking about a particular problem and I was asking you to find the length of something, I would only have to say find AB without the line on top of it. It makes it easier to write, to type, to talk about. When we refer to the physical segment, if you were to be, I don't know, building like a house out of popsicle sticks, you'd be referring to the actual physical popsicle stick as opposed to the length that you would need it as. So just different contexts for the same thing. This is one of those details that may look weird at first, but give it a week or so and you won't think twice about it. The other detail that students feel similarly about, that why the heck are there 2 different things, is the word equal versus the word congruent. We use the word same a lot of times. My pencil is the same as your pencil. In math, though, we have 2 different ways to refer to the word same. We have equal and we have congruent. When we discuss equality, we're dealing with the relationships between sizes, lengths, widths. When we deal with equality, we're dealing with numbers. We're dealing with measurement. We're trying to say that their measurements are the same, that the length of this pencil is 5 inches and the length of your pencil are 5 inches, so 5 inches equals 5 inches. When you deal with equality, you are dealing with numbers. Whereas when you deal with congruence, and notice the congruent symbol has the little squiggle on top, congruence deals with shapes. This is when you say that this shape, this segment, is the same as another segment, we use congruence. 2 objects are said to be congruent if one can be exactly superimposed on the other. If you could have a particular board of this house, and I could swap it out with another board that is the same, we're dealing with congruence because you're referring to the objects being physically swapped one for the other. If you want to then refer to the measurement of a particular board of a house, you'd be saying that one board is 20 feet, the other board is 20 feet, so they are equal. Both of these words very often talk about the word same. One of them is dealing with measurement, while the other one is dealing with shapes. All right, so because we have weirdness kind of details regarding notation, let's take a second to look at it. The first one says if 2 or more segments in a diagram are labeled with the same number of hash marks or tick marks, those segments are congruent. Looking at this, what we're doing is we're saying that this length, or I'm sorry, this segment and this segment are the same, meaning one can be swapped for the other. So how do we write that? Well, when we talk about congruence, we're referring to the idea that they can be switched. So that congruent symbol needs to be in place. Because I'm talking about the physical object itself, there are no numbers in this picture, then I'm going to talk about segment AD being congruent to segment BC, because an object is congruent to an object. Same thing for the double tick marks. Those that are marked, let me get another color, with the double hash marks or double tick marks are there to tell you that that object that is from D to B could be reversed with the same object from A to B. Objects are congruent to objects. One thing to note is that the AD has a line segment on top, the equals or the congruent symbol has its squiggle, and the BC has the segment on top of it as well. The second one says, if two or more segments in a diagram are labeled with the same measurement, those segments are equal. Because there are numbers present, we're saying that the measurements are equal to each other. So in this particular case, because we're dealing with measurement, I'm going to use the notation without the segment on top. I know it sounds very detail-oriented, and it is, but I do still want to talk about it so that you know how to read math. This top one here is saying that segment AD is the exact same as segment BC. Same being congruent. The two can be switched and the shape would be no different. The second one is saying that the measurements are the same. The numbers are equal. So the length between two things is the same. Very detailed, but again, some students look at something and they don't recognize what is this trying to tell me. We just have to learn how to read geometry. All right, definition of a midpoint. Midpoint is something that was defined in your vocabulary. Midpoint is that middle point. It's a point that divides a segment into two congruent or equal segments. Well, if we talk about congruent, what's that going to look like? If we talk about equal, what is that going to look like? When we discuss congruence, these little hash marks are present. I'm saying that this object from P to M and the object from M to Q are the same so that they could be reversed and the segment would be the same. Notice the notation, each of them are wearing all their little tops. When we discuss equal, we're saying now that the measurement, the ruler that you would use to measure, has the exact same measurement from P to M as it does from M to Q. The idea of midpoint is that it is this point that's doing it, but you have to ask yourself when you're talking or writing or reading, is it, again, dealing with measurement or dealing with an object? All right, so here's some things to look at. 4A, it says M is the midpoint of segment PQ. Okay, that means that M is exactly in the middle. It says find MQ and find PQ. Notice there's no line on top. So this is asking to find the measurement between M and Q, and then find the measurement of PQ. Well, since these things are equal, because it's the midpoint, because they're the same, I know that that length has to be 12, and that the total length would have to be 24. So we'd say MQ equals 12, PQ equals 24. While you might think that the notation is funny, why can't we just put lines on top of all of it? The way it's read, MQ equals 12, PQ equals 24, saves me from having to draw or write or type that little thing on top as well. So it really does help out. On letter B, it says PQ equals 62. The length from P to Q is 62 units. Find PM, meaning the length from P to M, and find the length from M to Q. Because the directions told me that M is the midpoint, and because there are little tick marks here, I know that those lengths are absolutely identical. So 62 split in half would be 31 and 31. So PM equals MQ. Their measurements are the same, and their measurements are 31, whatever the units are. Letter C. Z is the midpoint of XY, segment XY. Let's draw it. Here's X, here's Y, Z is in the center. If XY is a total of 27, it's asking me to find XZ. So half of 27, and that would be your measurement for XZ. DC is a segment bisector of segment AB. So here's segment AB. DC is a segment bisector. And notice DC is a ray. I don't think we've talked much about them yet, but it starts at D and goes towards C. Given the fact that it's a segment bisector, it's telling me that it's cutting the segment in half. If the length of AD equals 10, then find the length of BD. Well, since it's a segment bisector, the other side is 10 as well. For these two, same concepts. Now we're dealing with algebraic expressions. For letter E, it says M is the midpoint of segment PQ. Find the length of PM, the length of MQ, and the length of PQ. What we have here now are algebraic expressions. Because M is the midpoint, the lengths are identical. Well, if the lengths are identical, their measurements are equal. And now we've created an equation. Do you remember how to solve an equation with variables on both sides? And this is where your algebra skills come in handy. Notice the problem doesn't stop by saying find X. The problem asks you to find the length of PM. So if 5 is X, then that length is 11. If 5 is X, this length is 11. So the whole length from P to Q must be 22. So PM equals MQ, they're both 11. PQ is 22. Letter F. What we're looking at here is it's now telling you that the length from P to Q is 62. This one has those little tick marks, so I know that these two lengths are equal. If those two lengths are equal, then this side must also be 3x minus 4. So I'm going to then say, actually, let's do it this way. If this whole length is 62 from P to Q, what's half of 62? This piece has got to be 31, as does that piece. And it's asking me to find the value of x. So I know 3x minus 4 has to be 31. So x equals 35 over 3, or 11 and 2/5. Regarding rounding, things like that, I'm fine with an improper fraction, I'm fine with a mixed number, I'm fine with a decimal. As long as all of your values are equivalent, then you should be fine. I only have a couple of examples left, but my recording is at about 14 minutes, so I'm going to go ahead and stop it and then make a second one.